Hi there. Today, we're going to be looking at sample spaces and probability. So it's our first day of probability, and we're just going to start looking at the introduction to it. So today we're going to look at sample spaces, tree diagrams, lists, and charts. So it's visually a way to look at the probability. We're going to look at theoretical probability and something called complements. We're going to look at calculating probability by area, and then experimental probabilities and real-life applications. So first thing we're going to talk about is finding the sample space. What that means is all the possible things that could happen. So you flip a coin and roll a six-sided die. How many possible outcomes are in the sample space? List all the possible outcomes. So there's a few ways we could do this. One way that we can do it is by just listing everything. So you could roll a one. So you could flip a tails and roll a one. You could flip a tails and roll a two. You could flip a tails and roll a three. You could flip a tails and four, tails five, tails six. Or you could get heads one, heads two, heads three, heads four, heads five, heads six. That's all the possible things that could happen. Another way that we can do this is by a chart. So there are 6 things that can happen on the dice. 1, 2, 3, 4, 5, 6. There are 2 things that can happen on the coin, heads or tails. So they're all listed here. So heads 1, heads 2, heads 3, heads 4, etc. We also have a thing called a tree diagram, which is really nice. So we can get heads or tails on the coin. And then the dice has 6 possible things. So the end of each tree branch here are all the things that could happen. Heads 1, heads 2, heads 3, heads 4, etc. So there's 3 possible ways that you could find everything that's in the sample space. So after doing that, after listing all the possible outcomes 3 different times in 3 different ways, we see there are 12 possible outcomes, and they are all listed here. All right. Oops. Next. A student taking a quiz randomly guesses the answers to 4 true-false questions. What is the probability of the student guessing exactly 2 correct answers? So there's a few ways that we could do this. Let's try a tree. Whoops. So they could get the correct answer or the incorrect answer. We don't care if it's true or false. They could just be correct or incorrect, and they have a 50% chance, if they're purely guessing, a 50% chance of being right. So that is the first problem. That's problem 1. They could be correct or incorrect then on problem 2. Then they have to answer problem 3. And then they have to answer problem 4. As you can see, a tree diagram can get really big really fast with a lot of answers. But they're all listed there for you. So exactly 2 correct answers. So let's see if I can change the color on this. Oh, we got right at the top there. Okay, so this one doesn't work because it has 4 correct answers. So if I go 1, 2, 3, that one has 3. So if I go correct, correct, incorrect, incorrect, this one will work. Correct, correct, incorrect, correct, this one won't work. That branch won't work. Correct, incorrect, correct, incorrect. So I can go down. This branch will work. Correct, correct, incorrect. So if I go down this branch, it will work. I could go down this branch and it will work. So I have this one, this one, this one, this one. Incorrect, incorrect, correct, correct. This one will work, and that's it. So there are 5 things that will work. There are 5 ways to get exactly 2 correct answers out of And then we count the end branches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16. 16 possible things that could happen. 5 of them are exactly 2 correct answers. So our probability is 5 out of 16. Or if we go 5 divided by 16, that is 0.3125, or about 31% chance. So if that's all a person did, they would get a 31% on their test pretty consistently. Please stop at any time to take notes. All right, when 2 6-sided die are rolled, there are 36 possible outcomes. They're all shown to you. Find the probability of each event. The sum is not 6. So this is what's called a complement. So the probability of A happening and the probability of not A happening together make 1. So either A happens or it doesn't happen. Together, they are the probability of 1. So the probability that we roll a 6 is there are 1, 2, 3, 4, 5 out of 36 ways to roll a 6. So 5 divided by 36 equals 0.139. So about 14% chance we're going to roll a 6. So the probability of not rolling a 6 prime, or we could just say not 6, like this, either way, is going to be the other 86%. Because these two things are complements, we have 6 and not 6, they have to add up to exactly 1. So 14 plus 86 equals 100%. All right? And those are called complements. So again, please rewind, pause, whatever you need to do to take notes. All right, so A, the probability of not 6 equals 86%. The sum is less than or equal to 9. Probability that we have less than or equal to 9. So how many things? Let's see, here's the 9s. So there are 6 things that don't qualify. So the probability of greater than 9, which is the opposite, is 6 out of 36, which is 1/6, which is about 17%. That means the probability of everything else, which is to say less than or equal to 9, is 1 minus 1/6, aka 5/6, or about 83%. So about 83% of the time, you'll get a 9 or less. All right, next we're going to look at area. You throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. Are you more likely to get 10 points or 0 points? We're going to assume that everyone is an equal shot at this and that your dart randomly hits the board without any skill. So what we need to be able to do is calculate the areas of the spaces. Area equals probability. So the radius of the circles inside is 3 inches, and the square then is 6 by 6. So that's going to make it 36 square inches for the total area. So our 10-point circle there has a 1-inch radius. Pi aren't round, pi r squared. So the area of a circle is pi r squared. So it's going to be pi times 1 squared. So it's going to be essentially 3.14. So the probability of hitting the little circle, the 10-point circle, is going to be 3.14 approximately over 36. divided by, you can use your pi button too if you want to and get a little bit more precise. So 0.087, about 9% chance of you getting 10 points. All right, now the 5-point circle is a little bit trickier. So again, pi r round, pi r squared. This time it's pi times 2 squared. So I have 4 times pi, which is approximately, well, I can't find my pi button, so 12.56. But we're going to subtract the 10-point circle. So we're going to go 12.56 minus 3.14, 9.42 out of that 36 inches to begin with. And that's going to be about 26%, 0.26. So that's about 26% of the time you will hit the 5-point circle, and so on. All right. Sometimes you do not know what the theoretical probability is. Sometimes you don't know what's in the bag. So each section of the spinner shown has the same area. The spinner was spun 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? So let's just talk about the theoretical probability real quick. Assuming that the spinner is fair and has an equal chance of stopping on each color, the probability of blue is 1/4 of the circle. Therefore, the probability is also 1/4. The probability of yellow is 1/4. The probability of red is 1/4. And the probability of green is 1/4. So when we look over here, our experimental probability of red was 5 out of 20, and that was 1/4, just as it should be. The probability of green was 9 out of 20. The probability of blue was 3 out of 20, and the probability of yellow was also 3 out of 20. So our answer is red. Red is the only one that did exactly what our theoretical probability said that it should do. Now, does this mean that the spinner is not fair? No, not necessarily. Real life rarely happens theoretically, so it should be close, but it won't be exact all the time. All right, in the United States, a survey of 2,184 adults aged 18 and over found that 1,328 of them have at least one pet. The types of pets these adults have are shown in the figure. What is the probability that a pet-owning adult chosen at random has a dog? So we've got all these people in a big room together. We randomly choose one of them. The probability that that person has a dog, there are 916 of them that have dogs out of 2,184 surveyed. So there you go. 916 divided by 2,184 equals 0.419, or about 42%. About 42% probability of picking someone out that has a dog. Hopefully you notice that all the probabilities are in between 0 and 1. A probability of 0 would mean it absolutely can't happen, and a probability of 1 mean it absolutely will happen. So for example, if I had a bag full of yellow marbles, the probability of pulling a red marble is 0 because there's no red marbles in the bag. The probability of pulling a yellow marble is 1 because it's all yellow marbles in the bag, and so on. If you tell me that the probability is 42, I'm going to tell you you're wrong because it has to be between 0 and 1. So make sure if you mean 42% that you say percent, because 1 is 100%. All right. And finally, your assignment. Go to bigideasmath.com, log on with Clever. There's a little bar, blue bar that says Clever. Click on that. It's your normal login. It's your normal Jeffco login you always use. Click on the assignments tab at the top. So at the very top, you'll see 3 tabs. Click on the assignment tab and then complete the assignment that is named 12.1, please. I would love to have it done before you leave class today, but if you don't finish, please do finish at home and get that submitted. You have to submit it. If you don't submit it, then I don't see it and you get a 0. So please make sure you do submit. Thank you very much for being here today. I appreciate it. Have a great day.